Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here begins the essay. The year 1973 witnessed the publication of a seminal work by Vinton, Cerf and Kahn, titled A Protocol for Packet Network Intercommunication. This paper, a cornerstone of modern networking, outlined a revolutionary approach to data transmission across disparate networks, laying the groundwork for the technology that would become the Internet. This essay undertakes a comprehensive, section-by-section examination of the paper's core assertions, evaluating its arguments, methodologies, and lasting influence on the evolution of network architecture. Section 1, Introduction to the Interconnection Problem. Cerf and Kahn begin by identifying a fundamental challenge enabling communication between diverse packet switching networks, each potentially employing unique addressing schemes, packet sizes, and reliability mechanisms. The central argument is that a common protocol layer, residing above the individual network protocols, can provide a uniform interface for internetwork communication. The authors astutely observe the inherent limitations of attempting to standardize the underlying network technologies themselves. Instead, they propose a more pragmatic solution, a shared language spoken by gateways connecting these networks. The elegance of this approach lies in its accommodation of heterogeneity, allowing existing networks to maintain their internal operations while still participating in a global internetwork. This initial premise, a recognition of the diverse landscape of early networking efforts, proves remarkably prescient in light of the Internet's subsequent growth and expansion. Section 2, Basic Network Model and Service Assumptions. In this section, the authors articulate the basic model upon which their protocol is built. They assume that individual networks provide, at best, unreliable packet delivery. Packets may be lost, duplicated, delayed or delivered out of order. The gateways between networks are similarly considered potentially fallible. This pessimistic assessment is not a sign of technological defeatism, but a necessary acknowledgement of the realities of early network infrastructure. It compels the development of a protocol robust enough to handle such uncertainties. Cerf and Kahn introduce the concept of an internetwork protocol that provides intoned reliability on top of these unreliable network services. This is a crucial point. The internetwork protocol does not rely on any single network to provide a reliable connection. Rather, it achieves reliability through its own mechanisms. Section 3, Protocol Overview, Functions and Message Formats. Cerf and Kahn now delve into the architectural details of the Internetwork protocol. They define key functions, including fragmentation and reassembly of packets, error control, flow control, and addressing. The protocol relies on a header attached to each packet, containing information such as source and destination addresses, sequence numbers, and control flags. Of particular significance is the scheme for addressing hosts across multiple networks. Each host is assigned a unique internetwork address, consisting of a network identifier and a host identifier within that network. This hierarchical addressing scheme allows packets to be routed efficiently across the internetwork. The authors also describe message formats, including the structure of the packet header and the semantics of individual fields. The clarity and precision of this section are commendable, providing a solid foundation for understanding the practical implementation of the protocol. Section 4, Detailed Protocol Mechanisms, Fragmentation and Reassembly. One of the significant claims in this section pertains to the treatment of fragmentation. Recognizing that different networks may have different maximum packet sizes, Cerf and Kahn propose a fragmentation mechanism that allows packets to be divided into smaller units for transmission across networks with smaller maximum transmission units. The reassembly of these fragments is performed at the destination host, not at intermediate gateways. This decision avoids adding complexity to the gateways and ensures that intoned reliability is maintained even if fragments are lost or duplicated. While this approach adds overhead to the destination host, it simplifies the overall network architecture and contributes to its robustness. The authors detail the fields within the packet header used to manage fragmentation and reassembly, illustrating the intricate coordination required to ensure correct packet delivery. The fragmentation offset field, indicating the position of a fragment within the original packet to accurate reassembly. Section 5 Error Control and Retransmission Mechanisms. Cerf and Kahn address the crucial issue of error control by incorporating a sequence number and acknowledgement scheme into the Internetwork protocol. Each packet is assigned a unique sequence number, allowing the destination host to detect missing or duplicated packets. The destination host sends acknowledgements back to the source host, confirming a receipt of packets. If the source host does not receive an acknowledgement within a specified time period, it retransmits the packet. This mechanism provides reliable intoned delivery, even in the presence of packet loss. The sophistication lies in the timers used to manage retransmissions. Setting these timers appropriately is critical. Too short and unnecessary retransmissions occur too long, and packet loss is not detected promptly. The authors acknowledge this trade-off and suggest adaptive timer algorithms that adjust to network conditions. Section 6 Flow Control and Congestion Management. The paper addresses the challenges of flow control, aiming to prevent a fast sender from overwhelming a slower receiver. Cerf and Kahn propose a window-based flow control mechanism, where the receiver advertises a window of available buffer space to the sender. The sender is not allowed to send more data than the size of the window without receiving an acknowledgement that frees up buffer space. This mechanism prevents the receiver from being flooded with packets it cannot process. While rudimentary by today's standards, this early flow control scheme represented a significant step towards managing network congestion. The authors acknowledge that this is a complex problem and suggest that more sophisticated flow control mechanisms may be needed in the future. The foresight shown here is remarkable, anticipating the need for more advanced congestion control algorithms to handle the growth and complexity of the Internet. Section 7 Gateway Functions and Routing Protocols. This section details the role of gateways in the Internetwork architecture. Gateways are responsible for forwarding packets between different networks. They must be able to translate addresses, fragment and reassemble packets, and perform routing. Cerf and Kahn propose a distributed routing algorithm, where each gateway maintains a routing table that indicates the best path to each destination network. The routing tables are updated periodically based on information exchanged between gateways. This distributed routing approach is essential for scalability and resilience. It allows the Internetwork to adapt to changes in network topology and traffic conditions. The authors acknowledge the challenges of designing robust and efficient routing algorithms, particularly in the face of network failures and congestion. The seeds of modern routing protocols, such as Border Gateway Protocol, are clearly evident in this section. Section 8 Addressing and Naming Conventions. The addressing scheme outlined in the paper is critical to the scalability of the Internetwork. Each host is assigned a unique Internetwork address, consisting of a network identifier and a host identifier. Within that network, this hierarchical addressing structure allows packets to be routed efficiently across the Internetwork. The authors also discuss the issue of naming conventions, recognizing that users need a way to refer to hosts using human-readable names, rather than numerical addresses. They propose a naming service that translates names into addresses. This is the precursor to the domain name system, which plays a vital role in the modern Internet. The author's vision of a user-friendly Internetwork, accessible through meaningful name, are estimate to their understanding of human factors in networked. Section 9 Protocol Performance and Simulation Results. Cerf and Kahn present simulation results to evaluate the performance of their proposed protocol. The simulations demonstrate that the protocol can achieve reliable intoned delivery even in the presence of packet loss and network congestion. The simulations also show that the protocol can scale to handle a large number of networks and hosts. While the simulation results are based on simplified network models, They provide valuable insights into the behavior of the protocol under different conditions. The authors acknowledge the limitations of the simulations and suggest that further research is needed to validate the protocol's performance in real-world networks. It is important to note that these simulations provided crucial validation of their design choices before actual implementation. Section 10 Implementation Considerations and Challenges. The authors address the practical challenges of implementing the Internetwork Protocol. They discuss issues such as buffer management, timer implementation, and gateway design. They also acknowledge the need for standardization to ensure interoperability between different implementations. The authors emphasize the importance of rigorous testing and debugging to identify and fix errors in the protocol implementation. The foresight they demonstrate in addressing these practical considerations is notable, ensuring that the protocol would be viable in real-world deployments. The recognition of the importance of standardization laid the groundwork for the future development of Internet standards. Section 11 Comparison with existing protocols. Cerf and Kahn contrast their Internetwork protocol with existing network protocols, highlighting its advantages in terms of flexibility, scalability, and robustness. They argue that their protocol is better suited to handling the challenges of internetworking than existing protocols, which were designed for single networks. The authors acknowledge that some existing protocols may offer better performance in specific situations but maintain that their protocol provides a more general and adaptable solution. This comparative analysis helps to contextualize the significance of their work and demonstrate its potential to revolutionize network architecture. Their assessment of the limitations of existing protocols proved remarkably accurate. Section 12 Subsequent revisions and criticisms. While Cerf and Kahn's protocol became the foundation for TCP/IP, it underwent subsequent revisions. Early criticisms focused on the complexity of the protocol and potential performance bottlenecks. Some researchers proposed alternative approaches to internetworking, but ultimately, the core principles of Cerf and Kahn's design prevailed. Later revisions addressed issues such as security, mobility, and quality of service. These revisions were driven by the evolving needs of the Internet and the increasing sophistication of network technology. It is a testament to the soundness of the original design that it could be adapted to meet these changing requirements. However, one may also appreciate how the constant evolution introduced unforeseen security, vulnerabilities. The enduring significance of a protocol for packet network intercommunication lies not only in its technical contributions but also in its conceptual framework. Cerf and Kahn's vision of a global internetwork, based on open standards and distributed control, has shaped the evolution of the Internet. Their pragmatic approach to addressing the challenges of network interoperability, combined with their attention to detail and their foresight, has created a lasting legacy. The claims presented within the paper, meticulously evaluated and validated through simulations and subsequent real-world implementations, have undeniably transformed the landscape of computer networking, paving the way for the interconnected world we inhabit today. The spirit of collaboration and innovation embodied in this paper continues to inspire researchers and engineers working to advance the frontiers of network technology. The paper serves as a reminder that careful theoretical work, coupled with a consideration for pragmatic implementation issues, is essential for creating technologies that can have a profound impact on society. The remarkable achievement of Cerf and Kahn is that they created a system whose future complexity and scale they could not possibly have envisioned, yet whose fundamental design principles remain relevant today.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.